In this video, I'm going to talk about detecting collision between a point and a triangular face in 3D. So we have this point and we want to detect when it's colliding with this triangular face. So we're going to talk about how to do that. Alright, so we start with a point, and then we're going to define 3 points of a triangular plane in 3D. And now, to determine if this point is colliding with this triangular face, we need to know the distance from the point to the plane. And to do that, we need the normal of the plane, because the shortest distance from this point to this plane is along the normal of the plane. So to get the normal vector of this plane, we can take the cross product of the vector from P1 to P3 and the vector from P1 to P2. Taking this cross product, we'll get the normal vector. Now that we have the normal vector, we want to think about the position of this point relative to the plane, this vector, and we want the normal component of this vector so that we can add that normal component, or actually the negative value of the normal component, to get the projected point on the plane. So we can project this vector onto the normal, do that using the dot product, and then we'll perform the vector addition of this position vector plus the negative of this positions vector's normal component. And that will give us the point on the plane. So now we can use this vector and set a threshold and say, if this vector is sufficiently small, we know that our point is close to the plane. So it could be colliding. But that's not enough, because we also need to know, is our point within the bounds of the triangle? Because this plane extends out in every direction forever. Like, the equation of this plane isn't bound to the triangle at all. So we need to figure out, once we have this projected point, is this projected point within the triangle? So to do that, we're going to draw lines. You can connect the projected point to each vertice of the triangle, and as you can see, that's going to give us 3 triangles. And then the sum of the areas of these triangles will equal the area of our triangular face only when the point is inside the triangle. Because as you can see, as we approach the edge, the blue and the red triangle alone are equal to the area of the triangle. Now they're equal to more than the area of the triangle. And we have this green triangle, right? So the sum of the areas is greater than the triangle when the point is outside of the triangle, and it's always equal to the triangle when it's inside the triangle. So that's it. We can use the combination of those 2 things, the distance to the plane and knowing if the projected point is inside the triangle, to figure out if we're colliding. So using those 2 values, you can do collision detection between a point in space and a triangular face. And this is useful for 3D collision detection in games and things like that. In the next video, I want to try to live code this and do a demonstration so you can see how this is going to work in code. Yeah, so if we're importing objects from Blender, we're probably not even going to need the first step of taking the cross product to find the normal. That data will be automatically included in the object, as you'll see in the next video. But I hope you enjoyed this video and got something out of it. And let me know what you think in the comments. If you have any questions, I'll be happy to address it. Thanks.